Unit 1.12, confirming continuity over an interval. Finding the domain. There are three scenarios to watch for when looking for a restriction on the domain. One, when you want to avoid having the denominator equal 0, because when it equals 0, it's going to be does not exist, or so I'm going to watch out when the x, for example here, the x cannot equal 1, because that's the domain restriction. A square root, you can't have the number under the square root be a negative, so it has to be 0. Whatever this adds up to has to be greater than 0 or higher. It has to equal 0 or higher. So for here, x has to be greater than or equal to 3 over 7. Because if you plug in negative 3 over 7 into x, the answer is 0, and square root of 0 is 0. And that's the smallest number you can have under the square root. And right here with natural logs, it's 2x plus 1 has to be greater than 0, and x greater than negative 1 over 2. Because it can't be, this cannot be 0. There's no natural log of 0. Sorry, I don't know why I wrote this. Yeah, whatever. Find the domain. I'm sorry about that just now. Find the domain of each function. So we're just going to start by factoring this out. X minus 1 over x. Cancel out these x's. Well, before we even cancel out the x's, I'm sorry. We know that because of the x down here, x cannot equal 0. So the domain is every number but 0. So negative infinity to 0, union 0, infinity. F of x equals 3x square root x plus 5 over x. There's the x down here. We know x cannot equal 0. And there's a square root right here. It has to be greater than 0. So x also has to be greater than or equal to negative 5. So greater than or equal to, so it means the minimum value can be negative 5. Can't equal 0. Union 0, and then every other number after that. So that's the domain right here. We know that the denominator, whatever you plug in, it cannot equal 0. X cannot equal 4. So for this to not equal 0, x cannot equal 4, because the square root of 4 is 2, and 2 minus 2 is 0. And the square root of x has to be greater than or equal to 0. So with all these restrictions in mind, the domain is 0, 4, union 4 to infinity. Natural log of x over x minus 4. We know that you cannot get a natural log of 0, so x over x minus 4 has to be greater than 0. We know the numerator cannot be 0. So x cannot be 0, because 0 divided by anything is going to be 0. It has to be greater than 0. We know the denominator cannot be 4, because then it'll make that 0. And as far as I can tell, those are the only restrictions we have. So the domain is negative infinity to 0, union 4 negative 50. It also can be any number from 0 to 4.